All right, so before the break, we went over the different types of chemical reactions. Okay, we talked about how we can identify them. We talked about how we can write them out. We talked about how we balance them. Okay, those are all important skills if we're going to move towards predicting the products of a chemical reaction. So I'm going to write a few down here, okay? And what I want you to do is kind of fill in the rest of it. So the first two will be, I'll give you the formula form. You'll write it out in words, identify the type and balance, and then I'll write three more that are in word form that you have to write in formulas and balance. Okay, all right. No, that's not the one I'll use. Okay, I'll let you work on those four because I ran out of room. I'll put the fifth one up after we go through the first two. Okay, so for number one, first off, what kind of reaction are we looking at here? A what? A combination or synthesis reaction. Sometimes people call it a combination reaction. Okay, so a synthesis. A synthesis reaction is what number one is, okay, because we're combining two elements to form a single compound. All right, so those two elements are written out in word form, okay, chlorine plus sodium gives us sodium chloride. Okay, and you can bet that on tomorrow's quiz, I'm going to ask you to do something very much like this. Okay, I'll give you some reactions, identify the types, write them out, balance them. Okay, all right, now we got to balance this whole thing. So we usually start with what's present in the highest number, as long as it's not a combustion reaction, and it's not. Okay, so I got two chlorines on this side, so I need to go over here and put a 2 in front of the sodium chloride. When I do that, of course, it gives me 2 sodiums, so I need to come back over here and make sure I have 2 sodiums on the other side. Okay, questions on number one? Okay. All right, so for question number 2, I've got magnesium, which is the metal, reacting with copper 2 sulfate, which is an ionic compound, and it contains a polyatomic ion. That's going to form copper and magnesium sulfate. So written out, that's going to look like this. Magnesium plus copper, Roman numeral 2, sulfate. How did I figure out it was a Roman numeral 2? Right, sulfate's a -2 charge, and I looked on my periodic table to double check if I had any metals in here that would need Roman numerals. Okay, so if this is a -2, this had to be a +2 because they were even, okay, in terms of numbers. All right, that's going to form copper. When copper's by itself, of course, it doesn't need a Roman numeral because it doesn't have a charge when it's by itself, okay, plus magnesium sulfate. Okay, and what kind of reaction is that? Single replacement, right? Okay, now we'll balance it. Done. Okay, already balanced everything in there as a 1 already. Okay, how many people have done number 3? Okay, right. Just need a few more minutes on that one. Okay, I'm going to put number 5 on here, and then we'll try number 3 after that. All right, let's have a look at number 3 here. Okay, so number 3, we've got butane, which is C4H10. So we'll have C4H10 reacting with oxygen gas, so plus O2, okay, and that's going to produce carbon dioxide, CO2, and water. All right, what kind of reaction is that? It's a combustion reaction, right? We've got something that's burning in the presence of oxygen. All right, so it's a combustion reaction. Okay, we got special balancing rules for combustion reactions. First is that we balance in alphabetical order, and the second one is the rule of 2. If we have an even number of carbons, we start with a 2. We do have an even number of carbons, so we'll start our balancing with a 2 here. Okay, now I'm going to balance alphabetically, so carbon first. 2 times 4 carbons is 8 carbons. So now there's 8 on both sides. Okay, then hydrogen comes next. 2 times 10 is 20. Okay, so 10 times 2 is 20 hydrogens. So now my hydrogens are all balanced. Now I've got to look at my oxygens. On the product side, I've got 16 oxygens in the carbon dioxide and another 10 in the water for a total of 26. Okay, so 13 times 2 is 26 oxygens. All right, questions on that one? Those are usually the trickiest ones. All right, how many people have done number 4? Okay, let's have a look at that one. Okay, so in number 4, we've got dinitrogen triphosphide, so a molecular compound, N2P3, okay, and it's breaking down. So it's not reacting with anything, it's just breaking down, okay, into nitrogen and phosphorus. Anything special I got to put on those two things? Ethan? Right, these are both molecular elements. That is, when they are by themselves, they come as a molecule and not as single atoms like most things do. All right, so we got N2 and P4. All right, so looking at this, nitrogen's already balanced, but obviously phosphorus is not. Okay, there's 3 of them on one side and 4 on the other. Lowest common multiple of 3 and 4 would be 12. Okay, so if I put a 4 here, that will give me 12 phosphorus on the reactant side. A 3 here gives me 12 phosphorus on the product side, okay, and this 4 gives me 8 nitrogens, so now I have 8 nitrogens on the other side. Okay, what kind of reaction is that? It's a decomposition reaction, right? Okay, we need a couple more minutes on number 5. Okay, give you a couple more minutes on that one. So on number 5, we have iron 3 oxide. Okay, so that's going to be iron with oxygen. Oxygen's always a -2. The iron here is a +3. That's what the Roman numeral tells me. So when I drop and swap, I get Fe2O3 for my compound formula. Okay, that's reacting with potassium permanganate. Potassium is K. Permanganate is a polyatomic ion. It's MnO4. It's a -1 and potassium is a +1, so that compound is fine the way it's written there. All right, when that reaction happens, I get as my products iron 3 permanganate, so that'll be iron with MnO4, except that now this is a +3 and this is a -1, so what am I going to need around the permanganate? I'm going to need brackets. And then I'm going to need a 3 outside of the brackets. Okay, and then I'm going to have potassium oxide. Okay, this is a -2 and this is a +1, so that's going to be K2O. All right, what kind of reaction is that? It's a it's a double replacement reaction. Okay, we have 2 ionic compounds reacting, 2 partners being switched. All right, so now we have to, oh, this is not going to work. Oh yeah, good. Okay, so we've got to balance this whole thing. Right now, I would say probably going to look at the oxygen first. I know that seems weird, but I think that's where I'm going to go. Okay, because I think if I start with the permanganate, I'm going to end up switching. So I'm going to start with oxygen, which is present as a 3. Okay, I'm going to put 3 of them over here. All right, when I do that, it gives me how many potassium? 6. Okay, so I'm going to come over here and make sure I've got 6. The reason I did that was I looked on this side and saw that the 2 things that were together on the reactant side had different numbers over here. Okay, as soon as I saw that, I thought, okay, what's the lowest common multiple of those 2 numbers? I'm going to go with that first. Okay, that's why I started with oxygen. I knew if I started with oxygen, I'd be able to get that 6 right away. Okay. All right, so now I've got 3 oxygens on both sides. I've got 6 potassiums on both sides. Okay, I need to put something here, a 2, in order to make my permanganates work. Now there's 6 permanganates, and by doing that, I made my irons balance. Okay, so now it's finished. That's a tricky one for balancing. Okay, is that ringing a bell for everybody from last week? Okay, so here's where we're headed. I would give you something like this. I would ask you to predict the products of a chemical reaction and give you only the reactants. Okay, so that's what I've done here. I've just said potassium iodide reacts with lead-2 nitrate. Okay, so what should I probably do right now? Write it out as an equation, at least what I have. Okay, that way I might be able to figure out what? Before I figure out what the products are, I might be able to figure out what type of reaction it is. Okay, probably from the reactants, because we notice if we look at all of the reaction types, the 5 we went over, they all start differently. Okay, they all have kind of a pattern for their reactants. All right, so potassium iodide is Ki. This is a -1, that's a +1, so it's good the way I've written it. Okay, reacts with lead-2 nitrate. Okay, so this is a 2+. Nitrate's a -1, so that's going to need brackets with a 2. All right, so those are my reactants. They are both ionic compounds. What's the only reaction type we went over that starts with 2 ionic compounds? Double replacement. Okay, so now I've written out my reactants and I've identified what kind of reaction is going on. Now I have to think, okay, what happens in a double replacement reaction? Okay, in a double replacement reaction, effectively all that happens is the metals switch. Okay, they switch partners so that I get 2 different ionic compounds on the other side. And that's the key, is I have to get 2 ionic compounds. So metal, nonmetal, metal, nonmetal. Okay, I can't have 2 metals and 2 nonmetals together. All right, so that means that potassium's new partner over here is going to be nitrate. And who's lead going to end up with? Iodine. Okay, that's the only other nonmetal left. Okay, so now I've written out who's with who. But I've just made 2 new ionic compounds, and I didn't swap and drop either of them. Is it a good idea to do so? Yes, it is. Okay, this is a +1, this is a -1, so potassium nitrate is fine the way I've written it. Okay, now lead, we were told, is a 2+. So it's 2+ here, iodine's a 1-, so I'm going to drop and swap and get PbI2 for that one. All right, so now I've just predicted the products of a reaction. Okay? I didn't have to guess, I just went with what happens in that kind of reaction, and then I made it happen. All right, so we have to be familiar with our 5 reaction types so that we can do that. Okay? Now, what have I got left to do? Balance. Balance is always last. Okay, and here's where I was saying, if you don't swap and drop correctly, you're going to be in real trouble. If I forget to swap and drop, I'm probably not going to make this balance. Okay, so I've got to make sure I've dropped and swapped everything first. All right, so now I'm going to back over here, probably start with nitrate. There's 2 of them on this side, so I'll make sure there are 2 on that side. When I do that, it gives me 2 potassiums. So I'm going to put a 2 here. That gives me 2 iodines. There's 2 iodines over there. 1 lead, 1 lead. Looks good. Okay, now I'm done. It's really not that much harder than what you've been doing. You're just not told what to write down for the products. You have to figure it out. But it's not like a guessing game. Okay, the products are pretty straightforward, or at least figuring out what they are is pretty straightforward, especially in a combustion reaction. Okay, if I give you a combustion reaction, what are the products? Right, water and CO2. It doesn't matter what the reactants are. If it's carbon, hydrogen, and oxygen, it's CO2 and water on the other side. That one's automatic. It's easy to predict. Okay. All right, let's try a different one here. Let's try okay, I'll give you a few minutes on that one. Nitrogen reacts with magnesium. Okay, let's have a look at this one. So nitrogen reacts with magnesium. Now, is nitrogen a special element? Yes, it is. Always comes as a 2. Okay, these are little tricks you always have to be on the lookout for, because you know I'll play them. Okay, I don't have a lot of tricks in my playbook, but this is one of them. Okay, so I have to remember that this is one of those. Here's the other trick that I told you about before. Okay, if these 2 things react, first off, what kind of reaction is this? Synthesis reaction. 2 elements are reacting with each other. Okay, they're going to form a single compound. What kind of compound are they going to make? They're going to make an ionic compound, because it's a metal and a non-metal. So when I write this ionic compound, what do I write first? The metal. Okay, you would be shocked how often I will catch people on that very trick, because I didn't write it in that order on the reactant side, and people will put the nitrogen first, forgetting that an ionic compound is metal first, non-metal second. Okay, it's a way to test not only whether you remember your reaction stuff, but also whether you remember your naming and writing chemical formula stuff. Okay, so we got to make sure, okay, when we write an ionic compound, metal, non-metal, metal always listed first. Okay, all right, so this is a 2+, this is a -1. Okay, so that's going to be MgCl2, okay, magnesium chloride. Okay, see a few people looking at me like I'm talking crazy. Oops, sorry, nitrogen. That's why you're looking at me crazy, because I'm crazy and I wrote the wrong thing. Okay, sorry, magnesium and nitrogen. This is a -3, this is a +2, so we're going to have Mg3 and 2. Okay, better. All right, so we got to make sure we drop and swap correctly, okay, when we do that. Now, I got to balance the whole thing, okay, got to balance the whole reaction, okay, and it looks like nitrogen's already okay, so all I have to do is put a 3 here for the magnesium and it'll be balanced. Okay, were the steps similar for both of those reactions? Okay, first thing I did is write down the formula form for the reactants. And then from there, I identified the reaction type. And then using my knowledge or my notes, whichever, okay, for reaction types, I figured out who should end up with who, and I wrote them down that way. I dropped and swapped any ionic compounds or special elements or whatever, okay, and then I balanced the reaction. It's pretty much the same for every single one of them. Okay, identify the type, okay, figure out what the products will be, look for special elements, drop and swap, okay, any ionic compounds, balance the reaction. Always the same set of steps. Okay. Everybody with me there? All right. Have you try another one here. Let's have you try this one. Okay, copper 1 sulfide breaks down. So for this one here, what kind of reaction are we looking at? Decomposition reaction. Okay, it's breaking down. So the first thing I want to do then is write the formula for copper 1 sulfide. So copper and sulfur are together. Okay, sulfur is a -2, copper is a +1 in this case. Okay, so that means we have Cu2S. All right, it's going to break down. So when it does that, I'm going to get copper as a metal and sulfur as a solid and as an 8. Because that's the way it comes when it's by itself. Okay, it's one of those special elements. We always have to be on the lookout for those, especially in single replacement reactions and decomposition reactions. That's where they're going to rear their heads, okay, is during those two kinds of reactions, because we end up with something alone in those two reaction types. Okay. All right, so now that I've predicted those products, okay, that's kind of my dropping, swapping, because there weren't any drops and swaps here. There was just looking for special elements. Now I can go back and balance. I should definitely balance the 8 first. It's the biggest number. So I'm going to put an 8 here, which gives me how many copper? 16. Okay, now it's balanced. It's a big number, but it's balanced. Okay. All right, so the big thing here, guys, is it's easy to get cocky with our knowledge, or what we think is our knowledge of the periodic table. Okay, start writing reactions, just putting things down and not double checking. Okay, it's really important to always double check that you haven't written something down that is a special element, or that you've swapped and dropped everything. Okay, just crucial that you don't forget that. Otherwise, it's really hard to get any marks because you mix up, okay, one of those numbers. All right, making a little bit more sense? Okay, I'm going to give you guys about a 3-4 minute break here, okay, and then we're going to kind of go through this in note form. Okay, so just a little bit of kind of review here on, first off, balancing, and then on, we'll go over kind of the notes part of the predicting stuff we just talked about. Okay, so the big thing here about why we balance a chemical reaction is that we have to obey the law of conservation of mass. Okay, the law of conservation of mass says that matter can't be created and it can't be destroyed. That means I have to have the same number and kind of all atoms on both the reactants and product side of a chemical reaction. Okay, that's why we balance them, is to ensure that that happens. Okay, we obviously use coefficients to balance the reaction. That is those big numbers that we write in, because if we have a reaction that looks like this one, okay, because we did this one earlier, okay, when I go through to balance this reaction, I don't change these little numbers. Okay, those little numbers are there because that's how that compound works. Okay, all I can do is change the amount of that compound. I can't change what the compound is. Changing the little numbers changes what the compound is. Putting in a coefficient like this changes the amount of it, and that's how I balance a reaction, is by changing the amount of it that I have to make sure I have the same amount on both sides. Okay, so that's the purpose of those coefficients. Okay, everybody all right with that? All right. Okay, so mass has to be conserved in a reaction. We talked about that because matter can't be created or destroyed. Okay, since all matter has mass, okay, the mass of the reactants must equal the mass of the products. Okay, and when we're making sure I have, you know, 2 potassium atoms on both sides and 2 nitrate ions on both sides, that's going to ensure that the mass is the same. If I ever had a reaction where the mass disappeared or mass changed, okay, then I've done something wrong in my measurement, because there's no way that the mass can change, right? Even if a gas is produced. Okay, and that was something that was misleading in early chemistry. In certain reactions where a gas was produced, the gas would escape. And gas has mass, and it would escape, and they would go, oh, something's wrong, because suddenly our products don't have the same mass as our reactants. What they were failing to see was that gases do have mass. And if they escape or are allowed to escape or are not contained, then we lose that mass. All right, and so, like I say, that led to a lot of measurement error early on. Okay, now we can contain those gases, have some kind of airtight container. Okay, things like that where mass can be contained. Okay. All right. So if I'm looking at this situation here, okay, so this is my reactants, the top box. Okay, in which one of the bottom boxes is mass conserved? Okay, I've got 10 reds, okay, and I've got 8 yellows, right? That's what I've got. Sorry, I don't have yellow, I have green. Okay, so I've got 10 reds up here, right? And I've got 8 yellows up in here. That means that whatever the products are, whichever one of these shows the law of conservation of mass being obeyed, it has to have 10 reds and 8 of the yellows. Obviously, C isn't right. There's far too little. Okay, mass there for that one to be right. Okay, there's way less stuff there. If I look at D, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8 yellows. So the yellows are conserved 2, 4, 6, 8, 10. Okay, I would say it's then probably D. Okay, that would show the products of that reaction where all mass has been conserved. Okay, obviously in B there aren't enough yellows there. There's only 5 yellows there instead of 8. Okay. Everyone all right with that? All right, so when we balance a chemical reaction, and this is stuff we've talked about, you guys are already pretty good at this. This is just the notes for it, okay? We make sure we have the reaction written out, and then we always start with what's present in the largest number. Unless it's a combustion reaction, those have separate rules, okay? For every other reaction type, okay, we start with what's present in the largest number, balance it first, and then just kind of move back and forth along the equation until we have it all balanced. Okay, so we just keep repeating step 2, okay, and with putting in coefficients until everything works out. All right, so what that looks like for this reaction here, okay, so I've got copper reacting with silver nitrate to produce silver and copper nitrate. All right, what I would start with here, okay, would probably be the nitrates. They're present in the largest number. There's a 2 beside it on this side. Everything else is a 1 right now. All right, so when I do that, okay, I'd come back over here and I would put a 2 in front of my silver nitrate. Okay, that would give me 2 silvers. So I would put a silver there to make the silver work, and then I would double check everything else. There's 1 copper, 2 silvers, 2 nitrates, 2 nitrates. Now the reaction is balanced. Okay, that'll work for you probably, I would say 95% of the time. That'll work right away, just like it just did there. Just go back and forth until it works. The other 5% of the time, sometimes it doesn't. And you start with 1 and you're like, oh, that's not going to work. If it doesn't work and you find yourself hopping back and forth, changing numbers, start with something else. Okay, erase what you've done, start with something else. So advisable to do this in pencil so that you can erase it if that happens. Most of the time, those 5% involve oxygen. Okay, oftentimes oxygen will need to be balanced last. Don't ask me why. It just always seems to work out that oxygen needs to be balanced last because it messes things up, okay, when we're balancing. So if you have that 5%, it's probably that you started with oxygen and it just didn't work out right the first time. Okay, start with something else, oxygen will fall into place if you do it last, okay, most of the time. Okay, so questions on how that works? You guys look like you were already pretty good at that. It's not too tough. Okay. All right, so predicting the products of a chemical reaction goes as follows. Okay, what's the first thing I need to do? The first thing I need to do is write them out like this. Write them out in formula form. Okay, so that I can see what kind of reaction I'm dealing with. Once I identify the type, then I can figure out who goes with who, drop and swap, check for special elements, and balance the reaction. All right, so you got 4 there. We've done a few already, so I'm going to let you try those 4, okay, and see how you do on those. All right, so like we said, first step is to write it like this. So that's already done, okay? The second step is that we need to figure out what kind of reaction is happening. So in our first one here, we've got calcium reacting with oxygen. They're both elements, so this is it's a synthesis reaction. All right, so in a synthesis reaction, we're going to make one single compound. In this case, it's going to be an ionic compound with a metal and a nonmetal. All right, now, whenever I make an ionic compound, I need to double check that it's been dropped and swapped. Oxygen's a -2, calcium's a +2, so that compound is fine the way I have it written. Okay, those two things cancel out. Now what I need to do is balance the whole reaction. I've got 2 oxygens over here. Now I have 2 oxygens on this side, but that gives me 2 calcium. So I need to go back over here and make sure I have 2 calcium, and now I'm done. All right. Questions on number 1? All right, for our second one, I have only one reactant. The only reaction type that starts with one single reactant is decomposition. All right, so in a decomposition reaction, I'm going to end up with the 2 elements by themselves that were in that compound. And in a decomposition reaction, I always need to watch for what? Right, the special elements, the molecular elements, the ones that come as 2s and 4s and 8s, okay? And in this case, I have the one that comes as an 8, okay? So sulfur is an 8. Now that I've done that, I got to go back and balance. An 8 here balances my sulfurs, and an 8 here balances my magnesiums. Okay? So we do have to be pretty familiar with our reaction types so that we can get the products predicted. Okay, and then it's a matter of, okay, I remember how to, drop and swap. I remember to look for the special elements, things like that. Okay, I'll give you a couple more minutes on 3 and 4, and then we'll go over those. Okay, so for number 3, I've got a carbon and hydrogen containing compound reacting with oxygen, which is what kind of reaction? Combustion. It's always combustion. And the products of a combustion reaction are always the same. Carbon dioxide and water. Okay. Combustion reactions have special balancing rules. Okay. I only need one of them for this one because I have an odd number of carbons. So all I need to do is balance alphabetically. Okay. So I'll start with carbon. There's 3 of them here. And now there are 3 of them on the product side. There are 8 hydrogens over here. And now there are 8 hydrogens on this side. Okay. I have 6 oxygens in the carbon dioxide, 3 times 2, plus 4 more in the water gives me 10. Okay, 5 times 2 is 10 oxygens, and now everything is balanced out. Questions on number 3? Okay, and then for number 4, I've got hydrogen chloride reacting with sodium hydroxide. What kind of reaction is that? It's a double replacement reaction, 2 ionic compounds. So in a double replacement reaction, okay, the metals switch partners. So that means that hydrogen ends up with hydroxide. In other words, it makes water, okay? And sodium ends up with chlorine. Okay? This is an acid-base neutralization reaction, okay? This is an acid because it's an ionic compound that contains hydrogen, okay? And this is a base because it's an ionic compound containing hydroxide, right? When they react, anytime an acid and a base react, you get water and a salt of some kind, not necessarily specifically that salt, but okay, a salt of some kind, another ionic compound dissolved in the water, okay? Anytime you neutralize an acid, that's what you get, right? Now I have to balance it. Actually, I need to check the drops and swaps. This is a +1, this is a -1, so that's good. +1, -1, so that's good. And it's already balanced because everything's a 1. Okay. If there are no little numbers, then it's already balanced. Okay. All right, questions on that one? All right, there's one reaction type that we didn't do in here in this 4, so here's the 5th one. I'm going to write it like this because there's something, a little kind of exception that we need to talk about using this reaction. copper reacts with magnesium fluoride? All right, so copper reacts with magnesium fluoride. So I got copper as an element, reacts with magnesium fluoride. So Mg with F, this is a 2 plus, this is a 1 minus, so we're looking at MgF2. Okay, what kind of reaction is that? Single replacement reaction. So that means copper and magnesium have to switch places. Okay, I know copper and magnesium have to switch because they're both metals. I have to switch the things that are alike. If this was chlorine, I would switch it with fluorine. Okay, all right, so I'm going to end up with magnesium by itself, and then copper ends up with fluorine. Which copper do I use? Okay, I use the most common charge, okay, because they didn't tell me, and there was no way for me to know in this reaction. Copper was an element when this started, okay? I was never told the charge in the name, so I go with the most common. That's the one that's listed first from left to right. So for copper, that should be 2 plus, yes? Okay, so if you're not told, you run into this situation, and it happens occasionally, okay, you go with the most common charge, which is the first one listed. Copper, 2 plus, okay? So that means CuF2. All right, and now we're done because everything's already balanced. Okay, there was 2 fluorines on the other side, everything else is a 1. All right, so that's that one little exception that you sometimes have to watch for because it does come up once in a while. Okay, you will have a quiz tomorrow. It will not have any predicting on it. It'll just be, here's some reactions, write them out. Okay, and then we'll look some more at this and maybe at some of the pre-lab stuff for Thursday.